Welcome to a new video which is about introduction to derivatives. This is the second video of the series, and in this video we will start to look at the rules of derivatives and then solve instructive examples. Without further ado, let's get started. Here guys, we have three rules, and in the first one we have f of x is equal to c. C means constant, by the way. Let me write it here. This is constant. And in this case, the derivative of f of x, which can be written as df divided by dx, and which is also equal to d divided by dx of c. Again, c is the constant, and in all cases the result is 0. In other words, the derivative of a constant value is 0, guys. In the second rule, we have if f of x is given to you as x to the power of n, and in this case the derivative of f of x can be written as, here the power is n, okay, that power comes to up front in front of x, as we see here, as a multiplier, and then we decrease the power by 1. In other words, f prime of x, which means the derivative of f of x, can be written as n times x to the power of n minus 1. We can give an example to first case. For example, we can say that the derivative of, let's say, 5, okay, derivative of 5 becomes 0. For the second case, we can say that, let's say, the derivative of x to the power of 3, okay, that prime means derivative, and this is equal to, that 3 comes in front of x as a multiplication times x to the power of, and we just decrease 3 by 1, as we see here, okay, as a rule. And if you subtract 1 from 3, then we have 2, so we just put here 2 as a power of x. And for the third case, if f of x is equal to u minus or plus v, in other words, these are two different functions depending on x, so those functions also have x value. For example, let's say f of x is, as u, I can put here, let's say 3x squared, okay, plus, I'm gonna here write plus, you can put here negative also, minus, it doesn't matter. As a v, you can say, let's say we have 5 to the power of x to the power of 5 times x to the power of 7. So in this case, we have u as 3x squared, v as 5 times x to the power of 7. So if we have something like that, then we can take the derivative separately, like take the derivative of u with respect to x, and then take the derivative of v with respect to x, and then if the sign between u and v is negative, then just put here negative also. If the sign between those functions is positive or plus, then we just put here plus also. So for this case, for example, if we have f of x as 3x squared plus 5x to the power of 7, then the derivative of f of x becomes 2 times 3, which is 6, x to the power of, we just decrease the power of x by 1, then we have x to the power of 1, so it just stays as it is, plus, then this 7 comes as a multiplication in front of x, but there is also 5. 5 times 7 becomes 35, x to the power of, and then we just decrease the power by 1, and then it becomes 6, guys. So these are the basic 3 rules that we have to know in order to grasp the subject of the differentiation and derivatives. And let's take a look at some examples related to these rules. And as a first example, guys, it says find the derivative of f of x for the following given functions. In the first case, f of x is given as 20, 23, and in this case, what is the value of the derivative of f of x? Here, because 2023 is a constant value, and in this case, the derivative of f of x is 0, of course. 0 is f prime. And for the second case, we have the same thing. 2 to the power of 50 is a constant value, okay? So because there is no x value on the right side, okay, here, That means, because there's nothing like this, so that means we only have number, which means that f of x is a constant value, and in this case the derivative again becomes 0 for the B. And for C, f of x is given as 5 plus square root of 21. Again, this square root of 21 is a constant value, okay? Whatever the result of square root of 21, it doesn't matter. Still, it's a real number. Plus 5 plus a real number is a real number, because C is a real number, which means a constant value. That means the derivative of f of x in C is also 0, guys. For the last case, we have f of x as pi plus e to the power of 2. Here also we have the constant values. You know that pi is 3.14 something and it goes to infinity. E is the same thing, 2.7 something. So on the right side we have a constant value. That means the derivative of f of x in this case is also 0, guys. And for the second question, we have f of x as x to the power of 7 plus 3 divided by 2 times x to the power of 4 plus 61. And in this case, what is the value of derivative of f of x? And again, we're going to have f prime of x, which means the derivative of f of x is this 7 comes in front of x, okay, as a multiplication. So we're going to have 7 times x to the power of, we just decrease the power by 1, so 7 becomes 6, plus 3 divided by 2 times this 4 comes in front of x as a multiplication, times x to the power of, and now we're gonna decrease the power by 1, so we're gonna have 3 here, and because 61 is a constant value, then we have here 0. And if we rewrite it, okay, f prime of x is 7x to the power of 6. Here we can just cross out 4 and 2. So we're going to have 2 here. 2 times 3 becomes 6. So we're going to have plus 6x to the power of 3 as a final answer. And let's take a look at our last question in this video. And in this question, guys, we have f of x as x to the power of 2 divided by 3 plus 5 divided by x to the power of 4 plus x to the power of square root of 3, and in this case, what is the value of the derivative of f of x? Here we will do something slightly different. Okay, f prime of x is equal to, here all what we're going to do is we will write all x values as a power. For example, actually before taking the derivative, let me write f of x first. Okay, this is not derivative, so f of x is equal to x to the power of 2 divided by 3 plus, here I'm gonna write 5 times x to the power of negative 4, guys. If you remember, 1 divided by x to the power of 4 can be written as x to the power of negative 4. This is what I did here. So I'm gonna rewrite all the x values as a power in the numerator, okay? So I'm gonna, if x is in the denominator part, then I'm gonna write it in the numerator part. Plus x to the power of square root of 3, guys. And now I can take the derivative of f in this case. So f prime of x is now 2 divided by 3 times x to the power of 2 divided by 3 minus 1. I'm gonna subtract 1 from power. Plus 5 times negative 4 times x to the power of, I'm going to subtract 1 from negative 4, so we're going to have negative 5 in this case, plus square root of 3 times x to the power of square root of 3 minus 1, guys. You cannot subtract 1 from square root of 3 because square root of 3 is a real number, so it stays as it is. Of course, you can subtract it by using the calculator, but you can keep it there as it is as well. So I'm gonna rewrite the whole term one more time. F of x, the derivative of f of x is 2 divided by 3 times x to the power of, here if you subtract 1 from 2 divided by 3, then we're gonna have negative 1 divided by 3, guys, we're gonna have here negative 20 x to the power of negative 5 plus square root of 3 times x to the power of square root of 3 minus 1, guys. You can rewrite the whole term one more time, like for example 2 divided by 3 x to the power of negative 1 divided by 3 can be written as 2 divided by 3 in the third root. Okay, here we're gonna have 3, we have x here. So you can rewrite this term one more time, but you can keep it there as it is also. These are the same things because. So this is the final answer, guys, we can say in this last question. If you have any question, you can put them in the comment section below. Thank you for watching and hopefully see you in the next video.